Hello everybody, so in this video we are going to be looking at solving quadratic equations by reasoning. Okay, so thinking through what the solutions to that quadratic equation are actually going to be. Alright, so let's find some solutions. Now before we actually look at these quadratic equations, let's recall something like 4 squared versus negative 4 squared. Okay, so when I have 4 squared, if I were to expand that out, that'd be the same thing as 4 times 4, which is going to give me 16. Okay, now with negative 4 quantity squared, what's being squared? The negative 4 is. So what's being multiplied by itself? Negative 4 times itself. So negative 4 times negative 4 is going to also give me positive 16. So we have two input values there, right? 4 and negative 4, that when I square them, I get the same output value of 16. All right, that's going to be a big concept as we start to look at these quadratic equations. So, checking out this warm-up, I've got 7 different quadratic equations here. And we're going to determine how many solutions each one has and what those solutions are. Okay, so like in the first one, we've got x squared equals 9. So, we're asking ourselves, what squared is equal to 9? What times itself equals 9? Well, there are two solutions there. There are two possible solutions. Okay, x could equal 3 or x could equal negative 3. Okay, those are my two solutions into this quadratic equation because 3 squared is 9, 3 times 3 is 9, and negative 3 squared, negative 3 times negative 3 is also 9. Okay? So if we look at the next one, we got x squared equals 0. Well, what times itself is equal to 0? There's only one possible solution there. The only thing times itself that equals 0 is 0. So x equals 0. Okay? So in the next one, we got x squared minus 1 equals 3. So something squared, something times itself, then we're going to take away 1 from that, and we're going to get 3. I think another way to think about that is if I just move this 1 to the other side, I get x squared equals 4. All right, so something squared, something times itself, is equal to 4. Well, there are two possible solutions there. X equals 2 or x equals negative 2. All right, so we have two solutions there, two possible solutions. And the last one, we got 2x squared, and the last one in this column. 2x squared is equal to 50. So something squared, if we think the order of operations, something is being squared and then multiplied by 2 in order to get 50. Okay, so maybe you're able to reason out that that something squared, that x squared part needs to be 25, right? 2 times 25 is 50. Another way to see that is if we divide both sides by 2, I'm going to get x squared equals 25. So there we see again, something squared, something times itself, is going to give me 25. So that could be x equals 5 or x equals negative 5. Maybe you're seeing a pattern here of getting opposites, right? 5 and negative 5, 2 and negative 2. But that's not always going to be the case. And we're going to see that kind of in this next column here. All right, so we have two solutions there. So going into the next one, we have x plus 1 times x plus 1. Well, another way of saying that is x plus 1 squared equals 0. Okay, so x plus 1 squared is equal to 0. So something times itself is going to give me 0, which means this something inside the parentheses here, what does that have to become? Well, something squared equals 0, that something needs to be 0. So x plus 1 has to become 0. Well, the only way for x plus 1 to be 0 is for x to be negative 1. Okay, so there's only one possible solution here. One solution. Because if I plug in that negative 1 plus 1 times negative 1 plus 1, that's going to be 0 times 0, which is going to equal 0. It's how we can always check our solutions to make sure they actually make sense. But there's no other possible way for x plus 1 squared to equal 0. All right, whereas when we get number 6, we have two completely different factors here, right? X and x minus 6. So we can break these off and set these factors equal to 0. We're going to see, well, there's nothing I need to do here. X can equal 0, but x could also equal positive 6. So this one has two solutions here. X could equal 0 and x could equal 6, because if I plugged in 0, let's just do that off to the side here. All right, 0 times 0 minus 6, well, that would be 0 times negative 6, which would equal 0. Checks out, okay? If I plug in 6, I get 6 times 6 minus 6. Well, 6 minus 6 is 0, so 6 times 0 equals 0. That also checks out. So we have two possible solutions there, but they aren't opposites of each other. They're two very completely different numbers, 0 and 6. Okay, so now we get to the last one. Notice that this one is different because we aren't able to, like, after I simplify this, x minus 1 times x minus 1, x minus 1 squared equals 4. But we don't have it equal to 0 like we were able to in number 5 and number 6. So we can't just say, okay, it's going to be 1, right? It's the opposite of what I'm seeing. Because we need to square a number in order to get 4. Well, what squared is 4? 2 and negative 2, which means this quantity inside the parentheses, that quantity needs to equal 2, or that quantity needs to equal negative 2. And if we solve both of these, x would equal 3, and then x would equal negative 1. Right? Let's review our solving steps here. We're just going to add 1 to both sides. 2 plus 1 is 3. Negative 2 plus 1 is negative 1. So if I were to plug those numbers back in, we have 3 minus 1 times 3 minus 1. So that'd be 2 times 2, which is 4. So that checks out. All right. Similarly, if I were to plug in negative 1 minus 1 times negative 1 minus 1, that's going to be negative 2 times negative 2, which is going to be also positive 4. So there we see we have two completely different answers because there were two ways for us to get 2 or negative 2. Okay? So that is how we are solving these equations, these quadratic equations, by thinking about what number needs to be squared. All right, so in the next section, we are going to up the ante a little bit. We're going to make these a little bit more difficult. So each of these is going to have two solutions. Let's figure out what they are. Okay, so we've got n squared plus 4 is equal to 404. So some number squared plus 4 is going to give me 404. So what is that n squared? What does that n squared need to equal? Well, if I just move this 4 over to the other side, I get n squared equals 400. Okay, so something squared is equal to 400. So what number times itself is equal to 400? Well, we can use our calculator and guess and check a little bit, try to find those numbers. Okay, and eventually we'll figure out that n will equal 20 and n will equal negative 20. 20 squared is 400, 20 times 20. Negative 20 squared is also 400, negative 20 times negative 20. All right. In the next one, we have 432 is equal to 3n squared. So again, let's try to get that n squared by itself. So divide both sides by 3. All right, so we're going to get n squared equals, and then 432, that's going to give me 100 and, brain is turning off this early morning. All right, so that's going to give me, calculator's not right by me, so we're going to actually do this off to the side. 144, there we go. N squared is equal to 144. So something squared is going to equal 144. So again, thinking about your numbers times itself, we're going to get two solutions there. N will equal positive 12, and n will equal negative 12. 12 squared is 144. Negative 12 squared is 144. And remember, you can always plug these back in. 3 times 12 squared. 12 squared is 144. 3 times 144 is 432. That checks out. Similarly, 3 times negative 12 squared. Negative 12 squared is also 144. 144 times 3, 432. So it all checks out there. Okay? Last two problems here, we see that it's not just a variable squared, but a quantity squared. So in number 3, we got 144 equals the quantity n plus 1 squared. So what squared is equal to 144? Well, we just did that on the previous problem, right? We figured that out to be 12 and negative 12, which means this quantity inside the parentheses there needs to be either 12 or negative 12. So n plus 1 could equal 12, or n plus 1 could equal negative 12. So if I solve both these equations, n would equal 11, and n would equal negative 13. All right, because if we think about, if n was 11, 11 plus 1 is 12. 12 squared is 144. If n was equal to negative 13, negative 13 plus 1 is negative 12. Negative 12 squared, negative 12 times negative 12, is also going to be positive 144. Okay, so in our very last one here, we've got n minus 5, quantity squared, minus 30 equals 70. So my first step is just going to be that quantity, getting that quantity squared by itself. All right, so we got n minus 5 squared is equal to 100. So what squared is going to give me 100? Well, that number needs to be 10. 10 times itself is 100, or negative 10, right? Negative 10 times negative 10 is also going to be 100. So if I split this off, n minus 5 could equal 10, or n minus 5 could equal negative 10. And if I were to solve both of these, n could equal 15. That's a bad 5. Let's try that again. 15. It's also a weird fancy 5. N could equal 15, or n could equal negative 5. There we have our two solutions to the quadratic that make it work, right? We could, sorry about that, cancel, plug that back in, right? 15 minus 5 is 10. 10 squared is 100. 100 minus 30 is equal to 70. If we plug in negative 5, negative 5 minus 5 is negative 10. Negative 10 squared is 100. 100 minus 30 is 70. So we can always plug these values back in to make sure that they actually make the equation work. Okay? We'll review this when I get back, but please now work on your homework for today. Check out that cool down in Schoology and those practice problems. You can skip number 7. If you have any questions, email me or stop in during AIM when I get back on Tuesday. All right? Have a good rest of your day.